What up, Internet? This is Chris coming at you from mathmeeting.com. And before you get started with this video, I just want to let you know that we do offer live tutoring from the comfort of your own computer, full detailed homework solutions for any math assignment, and there is a complete list of all the free math videos that I've made that you can watch. All of this is at mathmeeting.com. Once again, mathmeeting.com. In the meantime, I hope you enjoy this video and take care. Hey everybody, welcome again to another one of my calculus videos. I'm going to teach you how to find the area under a curve. And in geometry, you probably learned how to find the area of a circle using the formula a equals pi r squared, or the area of a rectangle using the formula a equals length times width. However, what if the shape that you're trying to find the area is not a circle or a triangle or a rectangle? What if it is a weird curved shape? Well, that is the cool thing about integrals, is that integrals allow you to find the area for any particular shape, any curve. So I'm going to teach you how to find the area in between two curves. So let's get started with example number 1. In this example, I want to find the area in between the curve negative x squared plus 10x minus 21 and the y-axis. And the y-axis can also be written as y equals 0. That's why I wrote it for you like that in green. And I also colored in the y-axis in green as well. And I colored in the curve negative x squared plus 10x minus 21 in blue. And the first thing you should do in these type of problems is always color in with rectangles the area which you're trying to find. So notice how I colored in the area we're trying to find in rectangles, because that makes it easier to see which is the top function and which one is the bottom function. So that brings us to this formula in the top right hand part of the screen. And the area in between two curves is equal to the integral from a to b of the top function minus the bottom function dx. And our a represents the lower x value where our two curves intersect, and our b represents our higher x value where our two curves intersect. Our top function is represented by the function which the top of the rectangles touch. Notice how every single rectangle, the top of them touch the function negative x squared plus 10x minus 21. So that is our top function. And our bottom function is the function which the bottom of the rectangles touch. Notice how every single rectangle, the bottom of them touch the curve y equals 0 or the y-axis. So the area in between these two curves is the integral. Our a, which is our low point of intersection, is 3. Our b, which is our high point of intersection, is 7. And the points in which the two curves intersect are usually not given to you, so usually you have to solve that algebraically, but I'm not going to waste time doing algebra in this video, because I'm just trying to teach you the concept of area under a curve. We have our lower point as 3, our higher point is 7, and then our top function is the function in which the top of the rectangles are touching. Notice how every single rectangle is touching the curve negative x squared plus 10x minus 21, so that's our top function, minus our bottom function. And our bottom function is the curve in which the bottom of the rectangles are touching. Notice how every single rectangle, the bottom of them are touching the curve y equals 0. And so that is our bottom function, is 0 dx. And this can be easily simplified. Anything subtracted by 0 is just itself. So if you solve this definite integral, that'll give you the exact area in between the curve y equals negative x squared plus 10x minus 21 and the y-axis. And I'm not going to waste time solving this definite integral, because you guys probably already know how to do that. And I also have a video showing you how to solve definite integrals, so I'm not going to waste time doing that. But if you solve this integral, it'll give you the exact area in between the two curves which I just showed you. So let's move on to another example. Here we have the area in between the y-axis and the curve x squared minus 10x plus 21. So this looks very similar to the last example, except this time the top curve is the y-axis and the bottom curve is the parabola x squared minus 10x plus 21. So let's plug all this information into our area formula. Our lower x value, where the curves intersect, is 3. Our high x value, where the curves intersect, is 7. And in my next video to come, I'm actually going to show you how to find the points algebraically where the two curves intersect. Our top function is y equals 0. And our bottom function is x squared minus 10x plus 21. And if we simplify this integral, it becomes the integral from 3 to 7 of negative x squared minus 10x plus 21 dx. So let's move on to our last example. Here I want to find the area in between the curve negative x squared plus 10x minus 21 and the curve x squared minus 10x plus 21. And notice that I colored in with rectangles the area that I'm trying to find. I highly recommend that you do that because it's easier to see. So notice that the top of every single one of these rectangles touches the blue curve, negative x squared plus 10x minus 21, and the bottom of every single one of these rectangles touches the green curve, which is x squared minus 10x plus 21. So knowing that, it's really easy to plug in all our information into our formula to find the area. So the area is equal to the integral of A, which is our low point of intersection, which is 3, to B, which is our high point of intersection, which is 7, our top function, which is the function which all the top of the rectangles touch, which is our blue function, negative x squared plus 10x plus 21, minus our bottom function. And notice how the bottom of every single one of our rectangles touches our green function, which is x squared minus 10x, x squared minus 10x plus 21 dx. So this can be simplified even further and becomes the integral from 3 to 7 of negative 2x squared plus 20x minus 42 dx. So I'm not going to waste time solving this definite integral because you probably already know how to do that. If you don't know how to solve definite integrals, I do have a video on solving definite integrals, so I suggest that you watch that. I just want to give you a basic idea on how to find the area under two curves using this integral formula. And it's really important that you draw rectangles in the area so you know which one is your top function and which one is your bottom function, and it's really important that you know where the two functions intersect. So in my next video I'm going to solve another problem like this, the area under curves, using integrals, and I'm going to solve the problem from start to finish, so to give you a complete understanding on how to solve these problems. But in the meantime, I hope this introduction gave you a better idea and gave you a good start on how to solve these area problems. If you like the way I teach, please subscribe to my YouTube channel. Also, if you need any extra help with live tutoring or homework solutions, please go to my website at mathmeeting.com. Once again, mathmeeting.com. So I hope you enjoyed this video, and take care.